Okay, so we read through it. What do we know? We know that we know at t equals 20. What do we know at t equals 20? We know that the velocity is 100 kilometers per hour. So we do have one specific point. When t is equal to 0, our velocity is equal to 0. Good. So we know the acceleration must be constant. So what letter would you like to use for a constant? Because acceleration has to equal something that doesn't change. Use fancy Greek letter? Use the fanciest Greek letter we know? Or I don't want to use plus, I don't want to use C because we always do plus C. And I guess we could use a lowercase c, but that often gets confused with an uppercase C, depending on the size of your font. Use an omega. How about just K? Because a constant K. You don't think using some Greek letter would make it easier? You want to use gamma? Am I good at making my gammas? It's like this. Is that gamma? Oh, it doesn't look good. Which omega? Alpha and omega. This.
It's fine.
Oh yeah, we could use any symbol. We don't want to use K. We don't want to use C. We want to use lambda. Is lambda like this? Let's use lambda just for fun. Use a llama. You could, if you can't draw a lambda, but you're really good at drawing llamas, you can draw a llama. Okay. We know that it stays the same number. And in fact, our last question with the item falling, where it was negative 9.8 because we could use gravity, then we could integrate our way through until we found something. Okay? Now, perhaps we have enough information here to integrate our way through to figure things out. We want our final answer in meters per second, so I'm going to convert these kilometers per hour to meters per second. I'll do the first one. Okay, 0. You do the other one. That way it's fair. I did one, you do one. How much? 360 meters per second? Yeah, it's got to be. It's more like 20.7 and, well, 27 and 7/9. 0.7 repeated. Because first we'd have to get how many that is, and then we have to divide, what would it be? 100 times 1,000. 100,000 divided by 360. 27 and 7/9. Good. Now taking that, now if we do our velocity equation, that's going to be the integral of lambda dt. So it's going to be lambda t plus c. And this is where our initial velocity of 0 at time 0 is really helpful, because if I plug in 0 here and 0 here, I can find out that c is equal to 0. So then our equation just becomes velocity is equal to lambda times t. Now our second point, the fact that we knew at 20 seconds it was going 100 kilometers an hour, or at 20 seconds it was going 27 and 7/9 meters per second, we can plug that in. And what does that mean? We can calculate what lambda is. Was it 27? Which reduces nicely to a fraction of 25 over 18. So now we know that our velocity function is actually 25 over 18 t. We want to find out how far it's traveled at 20 seconds. So we can integrate again to find our displacement. Of course, we also know that at time 0 it has not traveled anything as well, right? So that means that our d value would equal 0 as well. $555. Did I put in a number wrong somewhere? You got half of that? What did I do? Oh, I didn't times it by, yeah, it is half of that. I typed in 18 instead of 36. Here we go. 25 divided by 36 times 400. That's what I did. 277.8, which math fraction? 2,500 over 9. Thank you. Love it when you type things into your calculator wrong. Points 8. Interesting that that's the same as our initial speed times 10. I hate it when things like that happen. Because then it makes you think, does that always happen? And then you end up doing math for 2 hours longer than you thought you should. All right. So we've got our homework listed at the bottom. We'll do that until the school burns down.